everyone, this is GATE 2023 Life Sciences Section P Biochemistry question number 33. A protein has 716 residues. The maximum number of disulfide bonds of different combination that can possibly be formed by these 7 residues is dash. Okay, so first we'll try to write the structure. So we have CH, SH. Suppose we have two cysteine molecules like this, NH2, amino acid. These two cysteine forms a disulfide bond, so we'll have okay. So in a given protein, this is the disulfide bond. So when there are two cysteine, only one disulfide bond can be formed in between them. Okay. So here in the question they have said that there are 7 cysteine molecules. 7 cysteines. Okay. And what is the maximum number of disulfide bonds that could be formed? Different combinations. So there are 7 cysteines. So how can we possibly have different combination of disulfide bonds within these 7 cysteine molecule in the same protein? So let's begin with first drawing the 7 cysteine residues. We'll only draw the SH residues of the cysteine. No need to draw the whole structure of cysteine. Okay, these are the the 7 cysteines. So let's consider this to be 1, residue number 1. This is 2. This is 3. This is 4. This is 5. This is 6 and 7. Okay, so we need to remember one thing, that a cysteine molecule can form a disulfide bond with the other cysteine. Okay, so one bond is formed between two cysteine, and now this cysteine cannot form a bond with another cysteine. Okay, why? Because the valency of sulfur is 2, so it can form only one disulfide bond. In a protein, it can form only one disulfide bond. Okay, so once if I draw a bond between 1 and 2, then this 1 and 2 cannot form other bonds with the rest of the residues. Okay, so only one bond can be formed between two cysteine residues in a protein. So if we consider cysteine residue number 1, okay, so if we pick this cysteine molecule, so this cysteine number 1 have 1, 2, 3, 4, 5, 6 choices. So the first cysteine molecule we have chosen has 6 choices. That is, this cysteine molecule can form a bond with 2, 3, 4, 5, 6 or 7. Okay, so it can form a bond either with 2, 3, 4, 5, 6 or 7. Okay, so the first cysteine residue has total of 6 choices. The first residue has 6 choices. Okay, so let's assume that it forms bond with disulfide bond with cysteine with residue number 2. Now we are left with 1 2 3 4 5 cysteine residue. So now we pick cysteine residue number 3. Now when we pick cysteine residue, third cysteine residue, it can form bond between 1, 2, 3 or 4. So it has 4 choices. So the second cysteine residue will have 4 choices. Okay. Suppose I made a choice between 7 and 3. Okay, I made a bond between 7 cysteine residue and third cysteine residue. Now we are only remaining with the 3 residues, 4, 5 and 6. Now let's pick residue number 4. So the residue number 4, as you can see, this residue have only 2 choices. It can either form bond with 6 or it can either form bond with 5. Okay. So the third residue has 2 choices. So let's assume we form a bond with 5. And now the 1 cysteine is remaining. It has no one to form the bond with. So we'll just leave it. So now to calculate different number of possible combinations, we have to multiply all these choices. Okay, the multiplication rules apply. So number of different combination, number of different possible combination is equal to 6 into 4 into 2, which is 48. Okay, so 48 different cysteine residues can form bond by these 7 cysteines. Okay, there are 48 different combinations that these 7 cysteine can form bond with. So now we are seeing a pattern here. So the formula which we can use to generalize the whole problem is n minus 1 factorial. Okay, this is the formula which we can use to calculate the cysteine residues, the number of bond forms in the cysteine in the n number of cysteine residue. Okay, so how we came to this formula? We'll take this example only. So if n is equal to 7, which is the which we solved here, n is equal to 7. So I'll use this formula n minus 1 factorial. So I'll use n minus 1, n minus 3, n minus 5. Okay, I'll use the factorial till I get the value to be 1. So n minus 1 will be 7 minus 1, 7 minus 3, 7 minus 5. I cannot go beyond 5. So 6 into 4 into 2, that is 48. Okay, so we'll be using the formula n minus 1 factorial. So the using formula is easier if we have very large, if the problem states many cysteine residues, like which we cannot solve it on pen and paper, then we can use this formula. Okay, suppose we have n is equal to 8. We can use the same formula, n minus 1, n minus 3, n minus 5. So 8 minus 1, 8 minus 3 and 8 minus 5, which is 7 into 5 into 2, which is 105. So 8 cysteine residues has 105 different possible combination that it can form the bonds among themselves. Okay, for 7 cysteine residue we got 48 different combination, and for 8 residues we have 105 different combinations. Thank you.